In this session, we're going to talk about Hadoop. Hadoop is an open source framework designed for distributed storage and processing of massive datasets. It was built to handle big data challenges like volume, variety, and velocity by using clusters of commodity hardware for parallel processing. For more tech interview materials, please visit our website, baoz8.com. Key components of Hadoop include 1. HDFS, Hadoop Distributed File System. Purpose, a fault-tolerant and scalable storage layer. Data is split into large blocks, default 128 megabytes or 256 megabytes. Blocks are distributed across multiple nodes for parallel storage. Each block is replicated, default, 3 copies across different nodes to ensure fault tolerance. Metadata management. The name node is the master server that keeps track of the metadata, e.g., file to block mappings and replication status. The data nodes store the actual block data and periodically send heartbeat signals to the name node. 2. MapReduce Purpose, a programming model for distributed data processing. There are 2 phases. Map phase breaks the input dataset into smaller chunks, key value pairs. Each chunk is processed in parallel on different nodes to generate intermediate key value outputs. Shuffle and sort. Intermediate results are grouped by key and sent to the appropriate reducer. Reduce phase aggregates intermediate outputs to produce the final result. Fault tolerance. If a task fails, MapReduce automatically reassigns it to another node with the same data. 3. Yarn, yet another resource negotiator. Purpose manages cluster resources and schedules tasks. Resource manager, central component that allocates resources for applications. Node Manager runs on each node to monitor resource usage and task execution. Yarn enables multiple applications, e.g., MapReduce, Spark, to run on the same Hadoop cluster. 4. Hadoop ecosystem tools Hive, SQL-like querying interface for HDFS data. Spark, in-memory data processing engine for faster computations. HBase, a NoSQL database for real-time reads-writes on HDFS. Pig, scripting platform for complex data transformations. Under the hood, here's what happens usually. 1. Data ingestion. A large dataset, e.g., web logs, clickstreams, or images, is uploaded into HDFS. Blocks are replicated and distributed across data nodes. 2. Job execution. A user submits a MapReduce job to process data. Yarn schedules the job, assigns resources, and coordinates task execution. Data processing happens locally on the nodes where the data resides, reducing network overhead. 3. Fault tolerance. If a data node fails, HDFS retrieves data from another replica. Failed MapReduce tasks are restarted on healthy nodes. Example use cases are log analysis, analyze terabytes of server logs to detect trends or errors. ETL pipelines, transform raw data into structured formats for downstream analytics. Genomic sequencing, process huge datasets for pattern recognition in genetics. Retail insights, analyze purchase history to recommend products in e-commerce platforms. Advantages of Hadoop are scalability, easily add nodes to handle growing data. Fault tolerance, data replication and task retries ensure reliability. Cost effective, runs on commodity hardware, reducing infrastructure costs. Open source ecosystem, extensible tools to meet diverse big data needs. Challenges and limitations include high latency, MapReduce is batch-oriented and unsuitable for real-time processing. Complex configuration, requires expertise for setup and maintenance. Storage overhead, replication triples the data storage requirements. Thanks for watching! For more tech interview materials, please visit baoz8.com.